Thank you. Yes, so I have the pleasure today of talking about a research program in Canada called the Multi-Partner Research Initiative, and we're now undergoing phase 2 of this program. And I was the instigator and leader of phase 1 of this program. So my name's Ken Lee, and I was a research scientist in Fisheries and Oceans Canada. I've spent my career working on oil spill response techniques. At one point, I was also director of Oceans and Atmosphere and CSRO to develop the spill response plan for Australia. And then came back to Fisheries and Oceans Canada, become the National Senior Advisor for Oil Spill Research, Preparedness and Response. And I just recently retired, but it seems like I'm still doing the same thing. So the MPRI program, phase 1 was between 2017 and 2022, and it was managed by Fisheries and Oceans Canada. And the goal was really to establish an integrated global research network to advance oil spill research in Canada and to enhance Canada's level of preparedness and response capability. We recognize in Canada that why are we doing oil spill research alone? It's a global issue, so let's work with other countries to get other people involved. So the focus on under MPRI program, when I put it together, was to advance scientific knowledge and science-based decision-making in oil spill response operations by improving the knowledge of current and emerging oil spill response and remediation strategies. Under phase 2, the project is now managed by a different federal agency, Natural Resources Canada, and they have a slightly different mandate. Under phase 1, the focus was on ship source spills. Under phase 2, we're focusing a little more on offshore spills from offshore oil and gas platforms because of the mandate of the Department of the Marine Environment, and also onshore oil spills from pipelines and oil spill related scenarios. And for phase 2, in the first phase, we had $60 million. In the second phase, we were looking at $30.37 million over 5 years. The overall funding for this project is actually more than that, because if you're an industrial partner, you put 50% in of your own funds, and if you're an academic sector, you're expected to put in 20%. The program that I'm going to talk about, phase 2 right now, to date, we've just funded 21 research projects that involve 65 organizations across 6 countries. This is a federal research fund in Canada where all the funding is going to outside agencies outside of the federal family. So this is really to build international collaborations. So the reason why I started this program was we needed some way to train the next generation of young scientists in Canada. So a lot of the focus is on funding academia and trying to, as I put, replace those gray hairs, no hairs like myself for the younger generation. And then networking with international partnerships between academia, industry, and key international organizations in oil spill research. And then, of course, we have engagement with numerous clients and stakeholders in Canada, the federal government, provinces and territories, Indigenous groups, the oil and gas industry, regulators, spill response organizations, and of course, the fisheries and other non-governmental organizations. It's called a multi-partner research initiative, not because of the multi-partnerships in the projects, but because it involves a number of federal agencies in Canada. As I mentioned, Natural Resources Canada, Fisheries and Oceans Canada, the regulator in Canada, Canadian Energy Regulator, Transport Canada, Canadian Coast Guard, and Environment Climate Change Canada. And we have an advisory committee for this program, which I lead, and I bring together Indigenous communities, the scientific community, the provinces, territories, and local communities, other stakeholders, and the marine industry. In terms of research priorities, what we looked at was how do we identify research priorities, and what we focused on was a Royal Society of Canada report on oil spill research that I led a number of years ago, Transport Canada's review on Canada's ship source oil spill preparedness and response regime. In the United States, we have the Interagency Coordinating Committee on Oil Pollution Research, or ICOPAR, which has just put out a plan for research in the US between 2022 and 2027. As we heard from Rob last day, we had the MPRI's 2022 International Oil Spill Science Conference. We took the recommendations from that conference. And then, of course, most recently, there's the National Academy of Sciences Recent Oil in the Sea4 report. And from this, we identified a number of areas that we thought we would focus on under this round of research: fate behavior, transport of oil in the environment, alternative response measures, oil detection and monitoring, biological effects of oil, physical recovery of oil, and response planning and decision making. So when we're looking at fate behavior and transport of oil in the environment, we put out a call for proposals. So these are the headers for the calls for proposals we put out. One was looking at natural attenuation potential and development of bioremediation strategies. A particular interest is in the Canadian Arctic and freshwater environments, and including conduct of controlled field studies and spill of opportunity studies. Development of experimental processes to investigate the formation and stability of oil emulsions in water under real world conditions. We know a lot about emulsification in a laboratory. We want to study emulsification under real world conditions and the influence of emulsified oil to the effectiveness of various oil spill response options. Looking at the fate of behavior and transport of oil and non-conventional oils in Canada, one thing that we're looking at with a lot of focus is diluted bitumen, because it's a product that's transported through our pipeline. Also looking at factors that influence oil droplet size, plume behavior and slick formation following surface and subsurface releases of freshwater and marine environments, and modeling of oil spill behavior following accidental subsurface pipeline releases and deep water blowouts, including the use of subsea dispersive injection. So now with the projects that are funded, just to give you an idea, following up on our last speaker, one of the projects that we're interested in is oil particle interactions in our waters of the north. This is a project led by Lake Superior State University. Lake Superior State University has recently set up a research institute with the U.S. Coast Guard in Sault Ste. Marie, Michigan, which is right here in the Great Lakes in Canada. And we have an interest in working on collaborations between Canada and the U.S. So though it's led by Lake Superior State University, it's collaborating with a number of Canadian partners on the other side of the border. And obviously, we know a lot about marine snow and oil particle interactions in marine waters, not that much in freshwater. Another project is development of bioremediation natural attenuation studies for Arctic marine beaches contaminated with hydrocarbons. So this is led by McGill University, and they're doing projects up in the Canadian Arctic. There's a large project led by the New Jersey Institute of Technology with a number of partners. Dr. Roger Prince is involved in this project, and he's here in the audience. Consortium for Evaluation of Mechanisms on Oil Fate Transport and Response Actions. The project's called Seymour. And of course, they're looking at emulsification, oil particle aggregates, underwater release, and three-dimensional modeling. So they covered a number of the things that we had our call for proposal on. And then another project by Concordia University, enhanced understanding of the fate behavior of oil for improving spill response in Canadian estuarine shorelines. We need a better understanding of how oil moves in estuarine shoreline environments so we can develop oil spill response technologies and have the science for decision making to support response. Moving on to alternative response measures. These are techniques, we call them alternative response, because in Canada, we're still looking at them as whether we can use them in the future or not legally. And this includes chemical oil dispersants, in case you're wondering, in Canada. But one of the things that we're looking at is in situ burning and spill treating agents. The reason for this is in Canada, in our legislation under Fisheries Act, it's illegal to put anything deleterious in the marine environment. So that includes chemical dispersants. So we don't have a pre-approval process. So we want to understand these processes better so we can change regulations to see if we can use them in the future. So the projects that we were looking at, we had development of smoke suppressants, because that's a major issue in situ burning, understanding the fate and behavior of oil on shoreline environments, and development of the next generation of spill treating agents, which includes chemical oil dispersants. As we heard yesterday, there's a lot of controversy over what's available in the future. In Canada, there's only one chemical oil dispersant approved for use, that's Corexit 9500A. So we want to expand that base. There are two projects that were focused on looking at smoke suppressants that were funded for in situ burnings of oil spilled on inland waters. One at the University of Western Ontario, now called Western University, and another one, development of ferrocene-based systems for smoke reduction, enhanced burn efficiency, and training of their use. And this project is being led by Lakeland College, which has a firefighting school, and one of our colleagues here from France is actually involved in this project. He's in the back of the room there. Development and evaluation of next generation of dispersants for the application in Canadian freshwater and estuarine environments. So what we're looking at is development of new formulations for chemical oil dispersants. One of the things that we're looking at is the generation of chemical dispersants using biosurfactants, because the public's always concerned about these chemicals put in the environment. So we're looking at chemical dispersants derived from things like fish waste and whether we can use chemical dispersants in large freshwater regions like the Great Lakes. And then also in terms of spill treating agents, development and evaluation of improved low toxicity surface washing agents for shoreline spill response, led by Concordia University in Montreal. And as I mentioned, each one of these projects have only identified the institution where the lead PI resides. And as you can notice, they're mostly led by Canadian universities, but the team under their network includes OSRL as well as industry and other groups. In terms of oil detection and monitoring, we wanted to advance unmanned surface and subsurface vehicles, oil spill response monitoring, evaluation and application of in situ oil sensors, improvement of special monitoring and applied response technologies. This is the US Coast Guard SMART protocol, which I sort of joke with US Coast Guard, said, well, it's not that smart, but we're trying to make it smarter. And then detection, quantification, and remediation of sunken oil is an interest that we also put a call out for. For monitoring and detection of oil in our waters of the north, this is part of that Lake Superior State Consortium. This is a wave tank facility. I believe it's at the University of Michigan in Ann Arbor, and they're developing sensors and also underwater vehicles for use in the Great Lakes. So this is one of their test facilities. Dalhousie University is actually developing a system for advancing the monitoring and response assessment of oil spills with integrated system of autonomous marine vehicles. They're also developing in situ oil sensors and predictive models. They actually developed a personal watercraft to do that can go out and do rapid monitoring. It can actually lower down water samplers in the water column. One of the things for this is, should we be using chemical oil dispersants at sea? If we want to monitor effectiveness on site during these operations, we can deploy a vehicle like this to look at the effectiveness of dispersion. In terms of enhancing the SMART protocol in the US, there's a program at Texas A&M University in the States where they're working on the SMART protocol, and we co-funded a project with them, an unmanned surface vehicle with modular design and multi-level sensor capability for oil spill detection, monitoring, and sampling. So both of these projects are developing techniques for monitoring operations at sea when we apply chemical dispersants or in situ burning. Obviously, biological effects of oil is a concern to everybody. One of the things is development of predictive risk assessment models, integrate data on oil fate behavior and toxicity, oil spill preparedness, response operations, and damage assessments. One of the things that we want to look at is refinement of whole of ecosystem models to predict the oil fate behavior, transport, and effects, including the effects of response operations, so to support NEPA decision making. And one of the things that we felt was very important, there's a lot of research done on toxicology, looking at single species tests in terms of toxicity. What we want to do is focus research that identifies or investigates the long-term ecological effects of oil spills in marine and freshwaters at the population and community levels. One of the reasons for this is if you look at the Gulf of Mexico studies on toxicity, if you look at the lab studies, 95% of the studies say, look, we find biological effects of using chemical oil dispersants. If you go and look at the field studies, 95% of the studies say we can't see anything in the field. Yeah. So we've got that paradox, and we're trying to say, look, really, let's get down to what we really want to understand in terms of toxicity is what's the impact on population and community levels. So there are a number of projects that are funded, once again, in the US, led by the US Geological Survey, was biological response to oil in our waters in the north. This is part of that consortium at Lake Superior State University. And then we have a research lab in Canada, the Huntsman Marine Science Center, where we're generating inputs for the calibration of oil spill effects models, filling data in gaps in marine and freshwater species of importance, application of oil spill biomonitoring systems. Under MPRI 1, just recently, the results from the research done at that lab, we published a special volume of aquatic toxicology on monitoring toxicity of oil spills, and there was 9 papers in one special volume. One of the things that we funded was the Atlantis model developed by C.S. Rowe in Australia, which was a fisheries management model. It's a whole of ecosystem model. And we said, let's expand this model. It's a well-known model used globally to explore the potential for unexpected contaminant risk, to evaluate resilience of the Salish Sea, which is this area in British Columbia off the Canadian coast, to build a whole ecosystem model to look at transport of oil, fate and effects, understanding socioeconomic impacts. So literally trying to come up with a whole ecosystem model that also takes into account what happens depending on what spill response technology we're going to use. So starting to make those big predictive models to have a look at, to provide support for decision-making in the future. And then, of course, as I mentioned, diluted bitumen is of interest in Canada. And so we have a study on fate effects of diluted bitumen in salmon-bearing rivers on Canada's west coast. Release of oily decanted water and toxicity of the resulting plume. And then we also have a project led by an Indigenous group looking at critical targeted lipid body burdens, marine and freshwater species in different environments, because a lot of our Indigenous peoples in Canada live on shellfish and things like that on the shoreline, and they're quite concerned about impacts on their communities. Physical recovery of oil and advancing oil absorbent solidifier technologies. We can always improve boom and skimming deployments and development of the next generation of decanting technologies for oil water separation at sea. And that's again because of when we boom and skim in Canada, we can't put the water back into the ocean because of our federal laws. So we have a project on enhancing recovery of oil at spill at sea, developing a semi-permeable curtains to enhance the flowability of oil and emulsions for skimming. So developing a new boom system that can be towed at a much faster rate because it's a semi-permeable boom. Development and evaluation, next generation environmentally friendly decanting technologies. I'm looking at on-site oil water separation disposal. One of my colleagues here from Canada is at this meeting, and they're looking at nanobubble technology to separate oil and water from water that's recovered from booms and skimming. Advancing porous materials for practical decanted water treatment, as I said, to bring that decanted water down to acceptable levels. And then finally, planning and decision-making, data accessibility and mobilization tools, including artificial intelligence and applications to advance the precision and accuracy of predictive models for decision-making oil spill response operations. And there was only one project funded by this. It's a project co-funded by the Arctic Council and the Norwegian government. And it's a shoreline circumpolar oil spill response viability analysis, ESCOSOVA, to support decision-making in the Arctic. Should we have oil spills in the Arctic, and what technologies you can use and what are the outcomes to help make those predictions. So I apologize, it's a very fast talk, but to cover 21 projects, 65 agencies, it's as fast as I can go. Thank you.
Excellent overview. Thank you, Ken. We've got time for some couple of questions.
Yes, Brian.
Hi, I'm Brian Mitchell from Rock Consulting. I just wanted to mention about the Lakeland College. They have a world-class firefighter training center there. And we do the burning. There, we also have facilities for studying oil, looking at detection above the surface of the water, etc. But interesting, one of the problems of the oil spill research, especially if you want to do burning work and you burn, well, we can burn there. The other one of where does the oil come from? And NRCan was supposed to give us the oil. They didn't have any, so Lakeland, the guys, they made a phone call. The next thing, a pickup truck arrives with some tubs of oil that were still warm out of the ground. So they got it from the local well. Great guys to work for. Fantastic organization.
Thanks, Brian.
Well, my argument is we can do in-situ burning anywhere, but maybe only once.
Anybody else? No, I mean, OSRL really, proud to be involved with this, just in a very sort of light area, but work that Doug Wallace and Andy Shura are doing at Dalhousie on the AEB stuff is really practical stuff. So OSRL and other people, other responders are really inputting into that and providing some operational realism to that work. Yeah, so just running on time. So yeah, thanks for the opportunity to be involved with those, and thank you, Ken.
Yes, and I'd just like to mention two things. One is, as I mentioned yesterday to some colleagues, I'm hoping that we can host another international conference with OSRL in Canada, perhaps in 2026. And so I'll put aside a budget for that. And one of the reasons for the reduction of the budget that you saw from 60 million to 30 is under MPRI 1, we still have 2 ongoing projects being supported by Fisheries and Oceans. And these are full-scale field trials where we want to release 60 tons of oil off the east coast of Canada to test chemical dispersants and in-situ burning. But that's a whole nother talk there.
Yeah, so watch this space. Maybe ITAC will be in Canada in a few years' time. I've just seen some of my colleagues' eyes light up. Okay, so moving swiftly on. Next, we have Hanley. Yeah, Hanley from